In this video, we will discuss about flip columns for maximum number of equal rows. You are given an m cross n binary matrix. You can choose any number of columns in the matrix and flip every cell in that column. That is, change the value of the cell from 0 to 1 or vice versa. Return the maximum number of rows that have all values equal after some number of flips. So what they are saying is that in the input, we are given an m cross n matrix, which is this, right? Now we can flip any number of columns in our matrix, and after any number of flips, you need to find out that how many maximum number of rows are there where all the elements are equal, right? So if I just draw the matrix of these three examples, so this one will be 0, 1, 1, 1, right? So in this, if you see, initially itself, there is one row in which all the values are equal. So then that means for this case, my minimum answer will be 1. Now I need to find that can I maximize it or not, right? So if I will flip this first column, then what will happen? It will become 1, 0. Other column will remain as is. So this row has become equal, but this is not, right? So in this case also, the answer is 1 only. Now if I flip this column, then what will happen? So first column will remain as is, second column will be flipped, so it will become 0, 0. Now again, only one row is there in which all the elements are equal. Now if I try to flip both of these columns, then what will happen? So this will become 1, 0, this will become 0, 0. Here also there is only one row that is equal, right? So in all the cases, the maximum answer for this particular case can be only 1, right? Now if we check for this particular case, so here if I draw the matrix, so it will be 0, 1, 1, 0, right? Now here, if you see, if I flip the first column, then what will happen? So initially there are no equal rows. Now if I flip this column, then it will become 1, 0 and the other column is also 1, 0. So it gives us two rows in which all the elements are equal. If I try to flip this column, then it will become 0, 0, 1, 1. Again, there are two rows that are equal. But if I flip both, then it will become 1, 0, 0, 1. Here no row is equal. So then that means in this particular case, my answer can be 2. Right? Now if we see for the third case, so for the third matrix, we have a 3 cross 3 matrix. So it is 0, 0, 0, 0, 0, 1, 1, 1, 0. Right? Now, if you try to closely look at these two rows, if you closely look at these two rows, in this row 0 and 0 is the same. If somehow this one also changes to 0, then this row will be counted, meaning in this row all the elements will become equal, right? And in this row, if you see, this one and this one is equal. So if you somehow change this 0 also to 1, then this row will also be counted. Or you can do vice versa also. If somehow you can change 1, 1 to 0, 0, then also they will become equal, because there is no restriction on the number of flips that you are applying on the columns, right? So if you closely look in these two rows, that they are having something common in them, right? So if you see, if I flip this particular column, then what will happen? It will become 0, 0, 1, 0, 0, 0, 1, 1, 1. This will become my matrix. Now if you see, these two rows have become equal now, right? When I am saying the two rows have become equal, I am saying that those two rows are having same number of elements within themselves, right? So here these two rows have become equal, right? We did only one flip and both of these two were sorted, but this one was not sorted, right? Now if let us suppose we had a row 1, 0, 1 and the other row is 0, 1, 0. Now in this also, if you see that if we flip this column, then what will happen? It will become 1, 1, 1, 0, 0, 0. They will become same. If I flip these two, then what will happen? It will become 0, 0, 0, 1, 1, 1. Right? So such type of rows will always become equal on flipping some number of columns. Now what is that such type of rows? So can you find out some combination between these two rows and between these two rows, and also here also? This is also one of the examples. So can you find out some common pattern in all of these rows? So if you will closely look, that this particular row and this particular row are nothing but the complement of each other. Complement meaning for 0 it is 1, for 1 it is 0. So if you see here, This is 0, this is 1, this is 0, this is 1, this is 1, this is 0. Complement. Here also this is 0, this is 1, this is 1, this is 0. Complement. This is 1, this is 0, this is 0, this is 1, this is 1, this is 0. Complement. So, whenever there are complement rows, after flipping some number of columns, I can make those rows equal. Why? Because they are having different element at the same place. Meaning, in these two rows, 0 and 0, and then here 1 and 1. In this cell and in this cell, this particular row is having same element, and in this row also, this particular cell and this particular cell are having the same element. And in this row, this was having a different element, and in this row, this cell was having a different element. That is why they share a common pattern. So if I will flip some number of columns, I will be able to make these rows equal. So if I count that how many maximum number of complementary rows are there, will I be able to get my answer? So see, I am saying that I will count the how many complement rows are there, right? Complement rows. Now, another thing if you see that when I flipped this column, then it became 1, 1, 1, 0, 0, 0, right? Now, if there was another row, 1, 0, 1 here, then what would it become? It would become 1, 1, 1. This also got changed. Why? Because closely look, this row and this row are equal, right? So, if upon flipping this column, this row is becoming equal, this row will definitely become equal because these two are same, right? If in place of this, 1, 0, 1, if you had 0, 1, 0, then also it would become 0, 0, 0. Why? Because these two are equal, right? So then that means complement rows and equal rows, if you find out, right? If you find out all the combinations of complement rows and equal rows, and then you find out that which combination is having maximum number of such rows, then you can return it as your answer, right? So see, actually, why am I saying maximum? Because in this particular case, if you see, if there was rows like this, 1, 0, 0 and 0, 1, 1. So in that case, what would happen is we had flipped this column, right? So these two would change to what? These would change to 1, 1, 0 and 0, 0, 1. So these are not equal, right? These are not equal. But if you would have flipped this particular column, then what would happen? Then these two would become 0, 0, 0 and 1, 1, 1. Then these two would become equal. Why? Because these two in itself are complementary rows of each other, right? So that is why one combination is this of the complement and equal rows, and one combination is this. So this is total 3 rows, this is total 2 rows, so maximum is 3. So 3 will be our answer. That is why I am saying that we will try to find out all the possible combinations of complement and equal rows, and then out of them whichever is the maximum, that will be our answer, right? Now the only question left here is to identify the equal and complement rows. So see, if this is my matrix, and if let us suppose this is a string, 1, 0, 1, and then this is a string 0, 1, 0, right? Then for the equal rows, you can count it in some map, right? So here this is 0, 1, 0 and this is 0, 1, 0. So in a map, keeping the key as a string equal to 0, 1, 0, you can count it as 2, right? You can count these two rows. But how are you going to count this 1, 0, 1 with these two? Because I want to count these 3 rows together, right? But this row is a complement of these two. So how can I convert all these 3 into a similar row or a common row so that I can count them together? So see, what if I compare the first element with all other elements? I'll tell you why am I saying that. So if you compare 1 with 1 itself, it will be true only, right? So if I just remove all this, so when you will compare this one with itself, it will be true only. When you will compare this one with 0, it will be false. When you will compare this one with this one, it will be true, right? Now if you check for this 0, this in itself will be equal. 0 compared with 1 will be false. Compared with 0, it will be true. So again this. Here 0 compared with itself will be true, compared with 1 false, compared with 0 true. So it will be again TFT. Then here 1 compared with itself will be true, compared with 0 false, compared with 0 false. So this will be TFF. Then This 0 compared in itself will be true, compared with this false, compared with this one false. So it will be TFF. Now if you closely look that all of these three have been converted to a similar format, and these two have been converted into a similar format. Now in your map, if you consider these as a string, then in the map for TFT, you will have the count as 3, and for TFF, you will have the count as 2. Now, why did we do that, and how these rows got converted to a common format? Because when these two rows were a complement of each other, so if this one was not equals to this 0, then this 0 will also be not equals to this one, because these are complement, right? If you see in these two cases, then when these two zeros were equal, then in the complement these ones will be also equal. And if this 0 and 1 were not equal, then in its complement also this 1 and 0 will not be equal. That is why we compare the first element with all the other elements to identify this pattern, and that is why we got a similar pattern for the complements. And on equal rows also we are applying same pattern, so those are anyways going to give you same only. But for the complement rows also it gave same, because of the fact that if there are two elements in a row that are equal or not equal, then in the complement row also they will be equal or not equal, right? So what we can do is that we can simply go in each of the rows, compare the first element of each row with all the other elements, and convert them to this T and FT pattern. And then for each row we can convert this into a string and count it inside our map. Then at the end, in the map, whatever is the maximum value, that is going to be our answer, right? So let's quickly code this out. So first of all, we will create a map. It will store a string as a key and the value will be an integer. Let's name it MP. Then we need to iterate for each rows. So for auto row in matrix, what we will do? Now we want to create a string out of that particular row, right? So we will create a string S which will be empty initially, and then we want all the cells in that particular row. So we will iterate in column. So call will start from 0. It will go till row dot size less than row dot size, and then call plus plus. Now inside this we need to check that if the current cell, that is row of call, if it is equals to the first cell, that is row of 0, then in that case, in our string, we will append a T, right? Otherwise, in the string, we will append an F, right? And once we are done for the current row, in the map, we will update the count of string by 1, right? Now, after this, we need to find out the maximum value from our map. So, we will take a variable maxi, which will be 0 initially. Then we will loop inside the map. So, it will give us, let's suppose, a pattern. So, pattern in MP. And then in the maxi, we need to take the maximum of maxi comma pattern dot second, because in second, it stores the count. In first, it stores the pattern, and in second, it stores the count, right? And at the end, you can return this maxi, right? Now here if you see, here we are iterating in all the rows, and here we are iterating in the columns. So basically number of rows into number of columns. And here in the worst case, what will happen, that this loop will run equal to the number of rows. So let us suppose there was no common pattern, there was no equal row, there was no complement row. In that case, your distinct number of patterns will be equal to the number of rows. So in worst case, this loop will run equal to the number of rows. So the overall time complexity of this particular code will be order of n into m or m into n, right? So let's quickly run this now. So our test cases are accepted. Let's submit this. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.